Continuation of the previous lecture of method of variation parameter. In this lecture we will discuss with some particular example to clear the previous lecture. In the previous lecture I think you face some problem because it's a theoretical expansion. If you recognize this lecture with this lecture, you can compare with the previous lecture and this lecture, you can easily understand what procedure is going on. sorry. So it's the procedure. Here is an example: d2y dx2 plus a square y equals to sec ax. It's sec ax. So it's a example to recognize or relate the previous lecture. d2y dx2 plus a square equals to sec ax. When we move to the previous topic, that is solution using CAPI model, D operator model, in that case you can understand how the different rule is used for this. On the right hand side is a sec ax, which is not a normal a particular integration, and the 5 different case we study that should not be applicable for this. In that case this should be applicable for the general case. Okay, 1 by dx or 1 by f dx, sorry. So here, according to the previous case, here we first find the auxiliary equation. Right hand side becomes 0. We just reduce the right hand side becomes 0. It's become d2y dx2 plus a square y equals to 0. That should be the reduced differential equation. In that case, the auxiliary equation becomes m square plus a square equals to 0, where m equals to plus minus I. Okay. So the complementary function becomes yc equals to c1 ax plus c2 sine ax. Just to relate with the previous definition, here we use the reduced differential equation. First case, you have to assume that the general solution of 2 is this one is done. Okay, and this one is completed and it's represented by this. So we'll move to the next step: c1 cos ax plus c2 sin ax. To find pi, which will be the next work, we have to show that cos ax and sin ax are linearly independent. How can I say that they are the linearly independent? If their Wronskian value is 0. And in the previous lecture, you can easily understand the Wronskian is this. This one is your Wronskian. If you want to find the Wronskian of y1, y2, this represents it's a second order determinant y1, y2, and the second row is y1 dash, that means the differentiation of y1 and y2 dash. So here we consider this Wronskian. The Wronskian of y1, y2, here we consider y1 equals to cos x and y2 equals to sin x according to this. c1 cos ax plus c2 sin ax, therefore y1 becomes cos ax and y2 becomes sin ax. Okay, this one. So the Wronskian is y1 y2, that is cos ax sin ax. Differentiation of cos x is minus a sin ax is a cos x, and when we expand this determinant, the result become a cos square x minus a plus a sin square x. Cos square x plus sin square x is 1, that is a not equals to 0, therefore y1 y2 are linearly independent solution. Then according to the rule, we just replace c1 c2 by b1x and b2x. Here is the continuation of the rule. Here is the continuation of the rule. We replace c1 c2 by b1 b2. Okay, so we move to here, replace this b1x cos x plus b2x cx. replace C1 by V1 and C2 by V2, which is a function of x. Next step is differentiation of this equation with respect to x. Rule says that this one is your rule. To determine V1 V2, we require two equation differentiating with respect to x one times. So here we take the differentiation with respect to x. Dyp v1 x cos x differentiation is minus a sin x, v1 is unchanged, sin x differentiation is a cos x, v2 is unchanged. When you differentiate v1 dash cos x plus v2 dash sin x. According to rule, it says that you should take this one becomes 0. v1 cos x plus v2 sin x should be 0 according to this rule. Here we mention the posterior of the rule. Okay, this one becomes 0. Rule says this one becomes 0. Okay, so here we consider this one becomes 0. Here we consider this one becomes 0. Next dyp, here we consider this one becomes 0. Okay, exactly this. Then the equation this becomes dyp is minus av1 sin x plus av2 cos x. Again we differentiation this equation, d square yp, it's become sin x differentiation is a cos x. So here we write minus a square v1 sin x. Cos x differentiation is minus a sin x. So here we write minus a square v2 cos x. And v1 dash cos x, so when you take the differentiation of v1 dash cos x, v2 dash sin x, nothing more. Okay, just here we take a common minus 1. Now the given equation is this, and we put the value of y, we replace the value of y, sorry, this one in the given equation, this one, this one in the given equation. We have in the given equation putting 1 3 4 1 3 4, 1 is the given equation, 3 and 4, just we put the value of dyp and d square yp in this, we get the result. D square yp becomes this, d square yp becomes this square p, just to put the value of a square p, after calculation the result becomes this. You also mentioned that we just solve for 2 and 5, it's your 5, this one is equal, this one is your equation number 2. If we solve these two equation, we find the value of v1 v2. Here is this two equation, we solving for v1 v2. You can choose any method, elimination method, a substitution method, cross multiplication method. We get the solution. v1 dash is this, v2 dash is this. Okay, that is your homework. You just calculate v1 dash and v2 dash from these two equation, this equation or this equation, okay, this equation or and this equation. Okay, so that is your that should be okay. When you solve these two equation, you just find v1 dash is this and v2 dash is this. Okay, so when v1 is this, then v1 dash, that means that should be the integration of this 1 by a tan x, just to get the integration, just to get the integration of this, sorry. So solving for v1 and v1 dash is this, integrating both sides, v x is 1 by a integration of tan x, that is minus 1 by a square. Just here we mistake a type, here is a typing mistake. There should be minus. There should be a minus integration of tan x. We know that 1 by a log mod sec x, and v2 is integration of this. v2 dash is 1 by a, so the integration of 1 by a should be integration of 1 by a dx, that is x by a. Therefore the corresponding function becomes this. v1 is this and v2 is this. That should be your particular integral. When we find the general solution, and the complementary function plus particular integral yc plus yp, so just write the yc c1 cos ax plus c2 sin ax, and yp is 1 minus 1 by x square log sec ax cos ax 1 by x sin ax, nothing more. So that's all for the first example. Next we move in the second example. In next class we'll again discuss another problem of method of variation parameter. Thank you for listening.